So this slide here is just kind of showing you, I guess, how we describe the solutions that are either that we give or that are in the extracellular fluid and how they affect the cells in the body and what have you. So let's talk about these three things first. So isotonic, basically isotonic is your happy equilibrium. So there's no water movement, nothing dangerous is going on. Your percentage of particle to fluid in all of the compartments is where it should be. So everybody's happy, right? Again, that's isotonic. Hypotonic. So let's look at the word, right? Hypo means low. Tonic means tonic is the particles, right? Particles that are in the solution or the solute that are in the solution. So this is talking about low solute or low tonicity, meaning we have a low osmolality. We have not that many particles inside. And we're going to talk about what happens, I think on the next slide, when the extracellular fluid is hypotonic. So we're not going to worry about it right now. And then hypertonic, this is just the opposite, right? It means we have a high osmolality, we have a high amount of particles in the extracellular space or intravascular, depending on where we're putting it. Sometimes we give these fluids that are hypertonic or hypotonic or isotonic because they do things, they cause different kinds of shifts, right? And we'll talk about that on the next slide, why that's happening. So don't worry about this. We'll look at isotonic after because it's really, really easy. Remember earlier we talked about hypotonic means we have a low tonicity in the extracellular space. So we're going to look at all this kind of like blue area here as your extracellular space. So what's going to happen? What did we talk about happens when we have to fluid, when we have an area of, we've got an area of kind of low concentration of particles and an area of high concentration of particles. Well, you can think of it as oncotic pressure, I guess, if you want. But the way I think of it is just basic osmosis. The water wants to move from an area of low concentration to an area of high concentration because it wants to even these spaces out. So if you think of this as what we were drawing earlier, this is the cell and this is the extracellular space, right? If we've given this extracellular space has let's put the water levels in, is hypotonic, right? And the intracellular space or inside the cells is hypertonic or normal, but it's has much more than the hypotonic on the outside. What's going to happen? The body wants to create equilibrium. It wants the percentage of solute to water to be equal. And it's clearly not. The percentage of solute to water outside of the cell in the extracellular space is very, very low. And then the percentage of solute inside is very, very high. And so what's going to happen? The water is going to move because we can't move the solute. Remember, we can't move the sodium potassium. We can't take all this sodium, potassium, whatever that's inside this cell here and push it out because that requires a sodium potassium pump. And energy and it's much more difficult. But osmosis happens very, very simply. And so in order to make these percentages over here equal, what do? We take some of the fluid out of this area of low concentration and we push it into the area of high concentration. And so we end up with less fluid here, more fluid here, but the percentage of these particles inside that fluid is relatively even. And so that's why when we give a hypotonic solution, or when any area is hypotonic, for example, your extracellular space is hypotonic, it creates a gradient. It creates a gradient, meaning there's a difference between the tonicity or the osmolality of 2 or 3 of the different spaces. As soon as you have that gradient difference, where you have very, very low osmolality on one side and normal or higher osmolality, the body is going to say, we have to fix this. We have to try to even this out and create a balance. And it's going to move the water to try to create that balance. It's going to move the water to try to dilute the area that's got a higher concentration of solute. And this doesn't just happen, well, we'll talk about it later. So hopefully that makes sense. And then, so using that logic then, what happens when the body or the extracellular space here has a hypertonic solution? So again, let's say this is your cell and this is your extracellular space. And remember, your extracellular space includes what? Includes your interstitial space, but more importantly, it includes your intravascular space. Why that's important is because that's where we're going to hook up an IV. We're going to put, for example, a hypertonic solution or a hypotonic solution into this intravascular space, right? And that's going to do something to the fluid. It's going to move, it's going to cause some kind of fluid movement. So again, let's say we've got now, again, we start with the same amount of fluid in each space. Remember, this is your intracellular space here. And this is your extracellular fluid compartment or space here. Okay. And now we've got, this is a hypertonic. We've got a lot of sodium here. And we've got our normal amount, or probably a little bit or whatever inside of. So what's going to happen, again, we want this to be even. We want to balance things out, but we can't move those particles across the membranes. We can't just take this sodium and move it over here to balance things out. What can we do? We can move the water. And so again, through natural osmosis, that water is going to go from an area of low concentration of solute to an area of high concentration of solute. So it's going to move like this. And so this is going to get less and less, so that now our percentage over here, so this is going to fill up. It's going to spread these around, and our percentage of particle to fluid is going to be relatively similar, and that's how we maintain homeostasis. And so knowing all of that, what I just said, what then happens if we give a fluid, or if the extracellular space is filled with an isotonic solution? Again, isotonic means basically it's similar to what's in the rest of the body. So if we're giving this solution, or if this solution here is in the extracellular space, is it going to move water in or out? No, because there's nothing to change. It's in its happy equilibrium space. It's got the similar percentage of particles to water in the intracellular space and in the extracellular space.